All right, guys, so I hope you recognize this handout from the beginning of the school year. I'm not talking about the year, I'm talking about school year way many months ago. We actually did all this to start the first week of school. This was factoring. There's many different types of factoring. We need to understand that factoring is simply a reverse distributive property. It's like doing distributive property backwards. So just a quick review right here. There's two terms. This is a binomial, 7th degree binomial. That's not what's important here. What is important is that you see something in common in the first term and the second term. There's obviously the multiple of 2 and the multiple of 2 in there, so you could pull out what? 2, bless you. Okay, not funny. But we also have x's. We have x to the 7th and x to the 2nd. So we could pull out a maximum of x squared. So what we call the GCF, what's greatest in common, or the greatest common factor in both terms is 2x squared. So you first have to be able to identify your greatest common factor, 2x squared, and then you pull it out and you rewrite what's left in parentheses. So if you were to pull out a 2x squared from the 2x to the 7th, obviously there's going to be no more 2 in there. That's why there's no 2 in this first term. And if you do pull out an x squared from an x to the 7th, that's really an x to the 5th left over. That's why there's an x to the 5th left over. Okay, so factoring is simply a reverse distributive property. Now, if you were to distribute 2x squared times x to the 5th, it'll take you back to the 2x to the 7th. 2x squared times negative 3, it'll take you back to the minus 6x squared. So factoring is a reverse distributive property. If you ever want to double check if you factored it correctly, you could distribute to see if it takes you back to where you started. We also learned how to factor quadratic trinomials. You guys remember quadratic trinomials? Like right here, it's pretty easy. You think what times what is 6, that if you combine together is 5. So what you do is you set up the situation, the parenthesis, x and x. Just a little review. Once again, we put an x right here and an x right here because there's an x squared. And that's how you're going to get the x squared. X times x starts you off with x squared. Now, if you have a number in front, it gets ugly. But if there's no number in front, you could set up this situation with the parentheses and with the x's, because x times x is x squared. And then after that, you simply think, what times what is the c value that if you combine together is the b value? So what times what is 6 that if you add together is 5? Well, 6 times 1, that's 6, but if you add it together, it's 7, it's not 5. So 2 and 3, and that would be the correct factorization right there, positive 2, positive 3. Now, if this would have been a negative 5, then it would have been a negative 2 times a negative 3, because that would have given you a positive 6. And if you added the negatives, it would get you a negative term. So you got to be careful with the signs, and you got to be able to think of the multiples of c that combine together to give you b. Now, sometimes you have to do a couple of steps of factoring, different types of factoring. For example, if you look at this one, there's 3 terms. It's a cubic trinomial. Not that that matters right here. But there's 3 terms. 1, 2, 3. What's in common? There's a 2 in all 3 terms, so you could pull out a 2. And there's also x's in all 3 terms, so you could pull out a total. The GCF is a 2x. Now, when you pull out a 2x from the first term, it's going to be an x squared. When you pull out a 2x from the second term, you're just going to have a 1x left. You don't even need to put the 1. You could just put x. When you pull out a 2x from negative 40x, you're going to have a negative 20x, and that's it. Now, the thing is, if you look at the inside of the parentheses, you could continue factoring, because this is a quadratic trinomial, x squared plus something x with the number at the end. So again, you could set up this situation where you have the parentheses, x and x. Now, this is not always going to work. Sometimes you're not going to be able to find the pair of numbers, and it would simply be not factorable, so you would stop right there. But in this case, negative 20, what times what is negative 20? That if you add together is positive 1, it's a positive 5 and a negative 4. And that's what we already have written down right here. And you simply take the 2x and you put it right in front. And that's what we call completely factoring. You guys got that? This is a review. We should all know this. Now, let me do this. Let me erase this stuff. Now, what's the whole purpose of factoring? Well, let's just pretend that this original expression, this cubic trinomial up here, this 2x to the third plus 2x minus 40x, let's pretend it said equals 0 and they told you to solve. Let's pretend it said equals 0 and they told you to solve. So before, it was just an expression, but if it has an equal sign and a number over here, then it's an equation that you could actually solve. Now, why would we want to factor? Well, you want to factor because when you factor, you end up with multiplication. Like right here, you have something times something times something. Right? there is no multiplication. It's something plus something, take away something, but now it's something times something times something. And if you had it equal 0, then you'd still have the equal 0. And we want this multiplication between these terms because we could apply the zero product property. Again, this is stuff from the past. Hopefully you remember. The zero product property is saying that if you have something times something times something and it equals 0, then the first something could be 0, or the second something could be 0, or the third something could be 0. So the zero product property allows you to split each of the things that you're multiplying and set them each equal to 0. So if you did go 2x, that could be 0. X plus 5, that could be 0. And x minus 4, that could be 0. And if you solved each of them, if you divide by 2 and divide by 2, you're going to see that x equals 0 because 0 divided by 2 is still 0. And this one will be x equals negative 5. And this one's going to be x equals 4. So, believe it or not, we used factoring to be able to split them using zero product property to be able to find the 3 answers that work for this cubic equation, if it were an equation. All right? So I'm kind of like using these old notes just to introduce what we're going to be doing today. So you need to be able to factor. Why do we want to be able to factor? So we could actually get multiplication in an equation that's equal to 0. That way we could split each of them equal to 0 and find the 3 answers. Now let me tell you this, guys. When you look at a cubic equation, it's going to have a maximum of 3 answers. And that's what we have here. 1, 2, 3 answers. If we were to pretend this were a function, if we were to pretend this were a function and get a graphing calculator, we know that the end behavior, as it goes to the left, it would be down to the bottom because it's odd. If you go to the right, it goes up to the top. We know that this function would cross the x-axis at 3 different x-intercept values, 3 real x-intercept values. As a matter of fact, I know exactly where it would cross the x-axis. If I had an xy plane, it would cross at 0, because of this answer 0. It would cross at negative 5 over here somewhere, and it would cross at positive 4 over here somewhere. So I know my graph, I could do a quick sketch, something like this. Right? No, that's wrong. Well, my point is, we could find the x-intercepts without even looking at the graph, because x-intercepts are answers. Let's move on to a skill that you guys may have forgotten, which is factoring by grouping. So when you have a polynomial, here's a cubic polynomial. The first thing to do is always try to pull out your GCF. Is there something in common in all 4 terms? No, there's not. So you can't pull out a GCF. So you're thinking, okay, if I split this into 2 groups, if I take a look at this first 2 terms and look at these last 2 terms, let's see if I could pull out something from the first group, pull out something from the second group, and let's see if there's something in common after I pull out in each of the groups. So the first thing to do would be to make some space between them. So notice these guys, there's now space between them. And what could you pull out of that first group? You could pull out x's. How many x's? X squared. So that's why there's x squared on the outside. If you were to take x squared out of there, which is what we did, then you are no longer going to have an x to the third, you're just going to have an x. If you pull out an x squared from here, that means that there is no more x squared, it's just a 1. If you were to distribute, it'll take you back to this. Now, because there's nothing to factor, and because I'm attempting to do factoring by grouping, at the very least, you could always pull out a 1. So if you pull out a positive 1, what's going to be left? The same thing, x plus 1. I know that sounds kind of ridiculous to pull out a 1, But if you notice on the inside of the parentheses, you have this x plus 1 and an x plus 1. So in the first group, you have something in common. In the second group, you have that same x plus 1 in common. So what we do is this. And I want to exaggerate the parentheses. I want to put the x plus 1 on the outside, and then I want to exaggerate these parentheses. So if I were to pull out this x plus 1, what would, if I take this out, what's going to be left? Just an x squared. If I were to take this x plus 1 out, what's going to be left? Just a plus 1. Okay? Now, obviously, if you look at this x plus 1 times this huge parenthesis with all this space, it looks ridiculous. So we're going to write it in the correct size, x plus 1 and x squared plus 1. That is factored. And once again, why do we want to factor? Just in case it were an equation, just in case you had an equal 0 right here, then you would put the equal 0 down here, and you could use zero product property to split these guys and solve. So if it were an equation, I would be able to say x plus 1 equals 0, x squared plus 1 equals 0. So this one's obvious, x equals -1, that's one answer. Over here, you end up with a little more entertainment. You're going to end up with x squared equals -1, and you would have to square root both sides, which means that x equals plus or minus. Now the square root of -1, that's really an I, so you get two imaginary answers there, right? So we get a total of 3 answers, x equals -1 and x equals plus or minus I. If it were an equation, it's not. So this worksheet these notes are from way back when, and it was just on factoring. But I'm letting you know, in today's section, we want to be able to factor to be able to solve equations. Okay, now, down here, it's when you have an a value that's not 1. Like before, if we take a look at this guy, before we wouldn't have this 6, and we would be able to set up this situation x, because x times x is x squared. However, I have a 6 now, so it's not x times x is x squared. I need a 6x. So you could start guessing and checking, right? You could put a 3 right here and a 2 right there, or it might be a 6 and a 1, or maybe a -3 and a -2, who knows? So instead of guessing and checking, we could use the above method where you multiply. Step 1 is to multiply a times c. 6 times -3, that's -18. Step 2 is to think of multiples of -18 that combine together to give you the middle value, -7. So that would be a -9 times +2. That gives you a -18, and if you add it together, it really does give you a -7. Now step 3 is to rewrite your quadratic trinomial as a quadratic polynomial, all right? You're going to take this middle value, -7x, and you're going to rewrite it as -9x plus 2x. So check this out. You're going to rewrite this -7x, you're going to rewrite it as -9x plus 2x. Where did I get those numbers from? From step 2. Now, why would I want to do that? Why would I want to change this 3-term quadratic expression to a 4-term quadratic expression? Because the 4-term ones, we could split them into 2 groups and factor by grouping. So make some space between them. In the first group, you could pull out a 3x, and you would have a 2x minus 3 left over. And in the second group, there's nothing to pull out, so at the very least, let's pull out a +1, and we will see that you still rewrite the 2x minus 3, and that's a great thing because you have that binomial in both groups. So we're going to pull out that 2x minus 3 from the whole thing, and what will be left is the 3x plus 1 inside, 3x plus 1. And this is just a review to get you feeling comfortable with factoring because you definitely need it on what we're doing today.